Hi everyone, my name is Julien Vehent. You just saw my face in the giant screen earlier. I'm from Mozilla. I actually didn't know I was going to be on the big screen, but that's kind of fancy. And I'm going to talk today about securing your websites, a hands-on guide to staying out of the news. That's essentially the goal we're aiming for here. I actually thought initially this was going to be a 20-minute talk. So I was like, oh yeah, cool. I can just put like 3 slides together and talk for 20 minutes. It's going to be great. And then realized, oh wait, I have a full hour. I need to make slides. It ended up with like 45 slides. So we have a lot to cover. But this is going to be fun, I promise. So who am I? I manage a small team of 5 people at Mozilla that focuses on the operational security of the Firefox core infrastructure. What's the Firefox core infrastructure? Well, we have a bunch of services that are behind Firefox, that when you run Firefox on your machine, then Firefox will talk to them. For example, if you have an account, we have a Firefox account system. If you synchronize your bookmarks, then we have a system for that as well. A system to send you web push notifications, for example, something that's very trendy nowadays in the web dev world, et cetera, et cetera. We have a couple dozen websites, and we also have a whole CI infrastructure to transform the code that our developers write into an actual Firefox binary that you run on your machine. And that runs across thousands of machines to test it across dozens and dozens of platforms, et cetera, et cetera. It's a pretty big environment. My job is to manage a team that keeps that secure. I'm a developer myself, back-end more than front-end, so don't quiz me too much on JavaScript type stuff, but if you want to know how to do crypto in the back-end or write some Go program, then I'm good with that. I also wrote a book that's called Securing DevOps, and that actually talks a lot about what we're going to cover today and how we secure things at Mozilla. So check it out if you want the 400 pages version of today's talk. It's interesting. So anyway, let's take a random target, right? 4chan, for example, why not? A high-quality provider of content on the internet. And look at what this site, how resistant this site is to common security controls that we like to enforce on our sites. And it actually gets an F. Not to beat on 4chan, I love 4chan, it's a great site. This is actually pretty common. We see a lot of sites on the internet, we look at a lot of sites on the internet, not just ours, but also how the sites out there are protected because it helps us understand what kind of controls we need to put in Firefox, right, to help developers build more secure sites. And this tool that we're looking at here is called the Mozilla Observatory. It's a platform that will go look at your website and look at various security controls, HTTP headers, look at your HTTPS configuration, even your SSH configuration if you want to, and it will grade it, and it will give you recommendations. And we started working on this project a couple of years ago. There are a few of us in the security teams that maintain this thing. You can go check it out, observatory.mozilla.org, and test your site with it. It's pretty popular. So 4chan gets an F. And the reason 4chan gets an F is essentially because it doesn't use the modern controls that we recommend developers to use today. One of them being content security policy, another being street transport security, et cetera, et cetera. And today I want to talk about these controls. I want to talk about how you can use them and leverage them on your websites to increase your security. So these things are complicated, right? This is a image I really like. If you are a web front-end developer, if you've worked with any sort of flavor of JavaScript lately, this will probably make you laugh. And on the security side, we look at a lot of websites, a lot of web applications, and they're not getting any simpler. Right? These things are complex, and even for really experienced developers, and I'm talking people who are really top-notch in the field, it's very easy to trip and to shoot yourself in the foot and to open your web application to a vulnerability you know everything about, and yet you didn't implement the control because there's just too much going on. So we obviously won't cover everything in web application security today. I'm going to pick a few areas that I think are important and a good place to get started. So if you're not an expert in security, don't worry, this is not an expert talk. This is actually targeted at folks who write websites. So we're going to talk about essentially 6 things here. The first one is content injection, because it's probably the most common type of issue we find on websites nowadays. We're going to talk about accepting user-generated content, so that if you want to write the next 4chan, you know how to do that. We're going to talk about cookie security. We're going to talk about authenticating users, which is pretty important. HTTPS, of course, can't have a Mozilla talk without talking about HTTPS. And we're also going to talk about testing security and what kind of tools you can use to verify if your websites are secure or not. So, content injection. Most websites accept data, right? And if you accept data, that means you're exposed to a user essentially injecting bad data into your website and doing terrible things to it. The prime example of that is actually pretty old. Who here remembers the MySpace XSS worm back from like 2005 or something? I see a few people. Yeah, that rings a bell, right? So the MySpace XSS worm was a piece of JavaScript that this Sammy guy, that's not him on the photo, wrote that essentially will post itself on MySpace. And it will post itself on somebody's profile page, and when somebody else visited that profile page, and the JavaScript will get executed, use the credentials of that new person, and replicate itself across MySpace. And within, I think, 20 hours, he had infected like 1 million pages. That was the first example of a web application worm, essentially, a JavaScript worm. And that's a prime example of how difficult it is to secure content that is generated by users on your website. The MySpace guys actually had done a pretty good job at protecting their website. They had escaped everything they could escape. They had blacklisted attributes, et cetera, and yet this Sammy guy managed to go through the net and write a worm that will replicate itself. So that's cross-site scripting, right? Cross-site scripting is a security exploit. That's a definition from the Mozilla Developer Network, MDN. Which allows an attacker to inject into a website malicious client-side code, JavaScript. This code is executed by the victim and lets the attacker bypass access controls and impersonate user. That's pretty bad. And it is very common today. You've probably seen that snippet. That's a typical example of how to trigger an XSS in an application. If someone can put that little chunk of HTML in a form of your app, and it's not sanitized properly, then it will most likely execute that alert box that we see underneath, and that's an XSS. And that's how most people test for a cross-site scripting attack. This is a real problem. This is data from the Mozilla Bug Bounty program. So we have a web bug bounty program that we use to invite researchers to poke at our website. If you find an issue on addons.mozilla.org, come tell us, we'll give you money, and we'll fix it. So we have that program going on all year long. People will come create bugs. Sandra talked about how you should submit bugs to Bugzilla. You can also do it for our websites. Please do so. And when you submit a security bug, we'll review it, we'll categorize it, and we'll rank it, and eventually we'll pay you money if it's eligible to our bug bounty program. And every once in a while, I go look at what kind of bugs we're getting. This is the categorization of vulnerabilities that are being reported to us. And the blue bar on the left, you probably can't read the bottom, but the blue bar on the left is cross-site scripting attacks. And it is, I forget exactly, but probably 5 to 6 times higher than any other type of attack we see on our website. Cross-site scripting are a huge problem. And even for applications like ours, and honestly, the folks who work on the web dev side at Mozilla are pretty senior, right? They know their stuff, and yet they fall into these kind of traps. So the remedy to this is content security policy. And that is often seen by a lot of web devs as something too complex to implement. It really isn't. This is all you need to put as an HTTP header in your application, and that's it. Start a new website, put a content security policy that's this basic, and start coding. And you'll see, you probably won't have to do much to it. When you start adding third-party libraries, etc. You need to put in your content security policy, but it's pretty easy because you do it over time, right? Of course, if you take 4chan, that's, I don't know, a 15-year-old application, and you try to do a CSP on it, that's probably going to be a lot more difficult. But if you do a new application, it's pretty straightforward. And what that does, so your application returns it to the browser, and the browser looks at it and says, OK, I have a content security policy that tells me that anything that's within the origin of the website, all the JavaScript that's there, is allowed. But I am not going to allow inline CSS or inline JavaScript. No inline style, no inline evaluation. I'm also not going to allow plugin execution. So no Flash, no things like that by default. And that, honestly, blocks 90% of XSS attacks. Sure, if you have someone who's really smart at these things and you have an application that's a bit complex, they might find a way around it. If you start looking at different types of browsers, there are ways to mess with the content type, et cetera, et cetera. And there are ways to disable the CSP. But start there, and it will get you covered for the most part. You can put that in your web application too. That's a snippet in the Go language. And that's a little middleware that's just sitting in front of my routes in an application. And all that does is add a response header for content security policy and the policy I just mentioned. So D4SRC star and object SRC none. It adds a second header, which is kind of the legacy CSP protection that's not really recommended today, but if you have or if you need to support older browsers, and that's always fun, you might want to have that one enabled as well, the XSS protection one. Here's a trick. You need to return the CSP on every HTTP response. That includes your 400s and your 500s as well. And I've actually seen applications get popped because they didn't return the CSP on the 400, and that was used to access, user cookies or something like that. So you want to have it on everything, not just on the pages you think are important. So that protects you against one type of user-generated content, but there are many types of user-generated content. And if you're writing the next Yelp application, you might have this guy writing Yelp critics on your app, and you really, really want to sandbox that as much as possible. And what we've seen in a lot of modern websites is that accepting user-generated content and rendering it and displaying it securely in your application is very difficult. So if you're building a new project and essentially you're being asked to, for example, take HTML and JavaScript and CSS generated by users and display it and render it, just run away screaming. This is extremely difficult to do. The first thing you want to make sure of is that you never reflect it. You never reflect that user-generated content in your main origin. So your main origin might be, for example, mywebsite.com, right? And if you take user content, you don't want to display that user content on mywebsite.com. Because if you do, then it has access to everything that my website content has access to, local storage, cookies, etc. So you want to put user-generated data on a separate domain that doesn't have cookie, and you want to insert it on your main website with an iframe. That's a little more complicated to implement than just taking user content and reflecting it. But it prevents the user content from having access to all the stuff that's stored inside of your origin. So here, for example, this is your website. And everything on there, on the right side and the left side, is trusted stuff that you've written. You've written those little snippets that display images and maps and whatnot, and you know that code, it's safe, you've audited it, it's great. But the part in the middle is the part that the user will generate and control. And that is radioactive waste. So you want that part isolated. The way you isolate it is that when the user submits a content, you put it on, for example, myappcdn.net, right? And you put an iframe on your main site that loads myappcdn.net. That way, myappcdn.net doesn't have access to anything that's on myapp.com. And the two environments are isolated. And that is going to save you from so many problems. If you look at really the top 10 website on the Alexa ranking, you'll see that they all do this. If you go to Facebook and you open an image on Facebook, you'll see that it loads the image under the domain fbcdn.net. The reason for that is because clever people have found ways to inject malware in like JPEG images, for example. So you think you're just taking an image from a user and displaying it on your main site, but in fact, you're opening an attack vector. The safe way to do that is to put it on a separate domain, and that way you don't have to worry about it. Cookie security. That's an area where there have been a lot of work over the years. But it's easy to forget how to do these things. And it's actually pretty simple to do it right. It only takes, really 4 things to remember. The first one is don't let JavaScript read your session cookies. And you can do that by setting the HTTP only flag on your cookies. Chances are most of your session cookies are just to be sent back by the browser every time they open a page. You don't care to manipulate it in JavaScript in the app, right? So just set the HTTP only, and the browser will not let JavaScript touch it. Don't send them in clear. So if your application is not strict HTTPS, if you still have HTTP pages, make sure that your session cookies have the secure flag set. And that will tell the browser to not send them on HTTP requests, only on HTTPS requests. Use a sensible expiration, expire or max age. That's just best practice. You probably don't want to have cookies that linger around for like 5 years, right? And the last one, who here knows what same site is? Excellent, nobody, which is great. Someone. All right, same site is a new feature that is being added to the major browsers. I think right now it might be nightly in Firefox. I think it's in Chrome, not sure which version, Opera as well. And what that does is it tells the browser that if a cookie has the same site strict attribute, that cookie must only be sent when the request is being generated from the same origin. What does that mean? Well, this is a cross-site request forgery attack. The cross-site request forgery attack is, for example, you're visiting badsite.net. You don't know it's a bad site. You're just visiting it. And badsite.net has some HTML in there that tells you to go fetch an image, for example, from Facebook. And your browser is like, OK, fine, you want me to fetch an image from Facebook? I'm going to fetch an image from Facebook. And as you do that, of course, the browser is going to say, hey, I have a bunch of cookies to send along that request because I have a bunch of cookies that are linked to Facebook. So it sends that request to Facebook and all the cookies with it, including your session cookies. So essentially, it's sending an authenticated request. You haven't really explicitly asked the browser to send that request to Facebook. Badsite.net did that by putting an element in their page that forced you to send content to Facebook. That is a cross-site request forgery attack. A third-party site is forcing you to send a request to a site where you're authenticated and potentially can use that to do bad stuff. Maybe what the browser thinks is a request to an image is in fact a request to an API endpoint that's going to purge your account entirely or do a bank transfer to some other site, something like that, something bad. And that's a pretty bad problem. And if you've written, pretty complex web application, at some point you've probably implemented what we call a CSRF token, which is essentially a way to say on Facebook, well, only accept requests if they have this token, which means you were on the site and you are the one who generated the request, and I trust you to process that next request. Great, but that's pretty complicated. CSRF tokens are not really elegant and often complex to implement, badly implemented, annoying to maintain. There's a new mechanism here that you want to keep an eye out for is same site. When you set a cookie, so for example, Facebook here is going to set their session cookie with the same site attribute. It tells the browser to only send that cookie if the request was generated from Facebook. So if badsite.net asks you to send something to Facebook, the browser will say, sure, I'm going to send that request to Facebook, but I'm not going to send that cookie with it, because it's not the request coming from Facebook. Did I melt all your brains? We're good? Excellent. There is more to read on that on the Mozilla Developer Network wiki page. I encourage you to look at it. It's still pretty new, but it's a lot simpler to understand that than to understand how to do CSRF tokens properly. So you should probably look into that. All right, authenticating users. Don't store user passwords, please. I mean, it keeps me in my job, which is great, but I can't remember how many times I've had to do incident response because the password database leaked. Not so much recently, but in the past, so many times. And passwords are a pain in the butt. You have to hash them properly, you have to keep the source around, you have to allow users to change them, et cetera, et cetera. Maybe you have to do some password complexity stuff. And eventually, if you do it wrong, you're going to end up on this website. So haveibeenpwned.com. That site is maintained by a guy called Troy Hunt, who regularly looks in the news for sites that have been hacked and tries to download the leaked databases, puts all of that into the service. You can put your email address in it, and it will tell you how many times your password has leaked. It's pretty terrifying. And yeah, I mean, he has something like 4 billion pwned accounts in there, which is ridiculous. So you don't want your site to end up in that list. Because that means you've essentially been hacked, which is bad, but you also were storing passwords, and those leaked as well. So nowadays, the right way to authenticate users is to rely on a third party. Unless you have some very specific needs, you should really just ask Facebook, Google, whatever, Yahoo, GitHub, or whatever identity provider you want, maybe all of them, to authenticate users for you. And that's OAuth, that's the OpenID Connect protocol. There are tons of libraries to do this in all languages. That saves you a lot of trouble. Essentially, you don't have to manage passwords in your database anymore. You just trust a third party to authenticate the user for you. Most of these providers will actually support two-factor authentication. If you've tried implementing two-factor authentication in your own website, it's really hard to do. Users will lose their second-factor devices. You need to have protocols to allow them to reset their devices, et cetera, et cetera. It's really hard to do. So you want to let people who have the money to implement these things correctly do it for you. Most of these providers will also do fraud detection. Every time you try to open your Facebook account from some other country, Facebook will ask you to verify that it's you by looking at photos of your friends or things like that. That is because Facebook is looking at your connection saying, that's not usually where that user is coming from. Maybe something's fishy going on here. So they ask you to do extra verification steps. Google will do the same thing. Google will actually send you an email every time you log into your account to warn you, hey, is it you? Or is it a fraudulent activity? So that is also very hard to implement yourself. So it's better if somebody else does it for you. And for your users, it's better too. They don't have to remember to have a different password on every site. That's what we've been recommending lately. People should have a 20-character password with 3 classes of characters and different on every site on the planet. I'm like, what? I can't even do that. And I have a password manager. So what happens is, for sure, my dad has the same password across all of his sites. And if one of these sites actually gets popped, and I'm sure at least 5 of them have by now, then everybody has his password. That's terrible. So the solution to that is to stop managing password in our applications and to ask users to go through these trusted identity providers to authenticate. All right. Let's go back to code a bit. When we write applications nowadays, we actually only write a very, very small portion of these applications, maybe between 5–10%. And the rest is dependencies. Who remember the left pad fiasco in the JavaScript? Yes. So the left pad fiasco essentially is that someone's NPM account got popped, and that left pad library was essentially compromised. Problem is, left pad is just a library. It's like 15 lines of code to align something, to pad something on the left side to align it to the right. It's the most basic piece of code you've ever written, and it was imported in a gazillions of other libraries. So by compromising that one little library, essentially, they got code into like all of the major frameworks, JavaScript frameworks, and everywhere in the Node.js ecosystem. It was pretty sad. But that's the reality of any sort of software development today, not just web development. The complexity for us is to actually keep an eye on the dependency tree and make sure that these dependencies are secure. There are tools to do that today, and you should use these tools. If you're on Node.js, use something like Greenkeeper or Snake. I actually have a little bit of a list here. I like Greenkeeper because they actually send you pull requests in your GitHub repo, so they will actually tell you, hey, you should update this version. You can review it and merge it. It's pretty seamless. PyUp.io is cool for Python. Snyk.io is an interesting service that does a few other languages. So these startups are popping up every week, essentially. A new one will come up next week for some other language or maybe replacing an existing one. So keep an eye out for those and make use of them. Because actually outdated dependencies is how company gets hacked. Equifax. So you want to keep an eye out for this. It's good hygiene. And that if you can do essentially good dependency management and the few things we talked about until now, your chances of getting hacked are decreasing significantly. And I can't do a security talk without talking about HTTPS. I don't know, I love that protocol. I've been digging into the cryptography world for 15 years now, and we have a few HTTPS-related scanning efforts going on at Mozilla that I love to play with. This site called badssl.com is managed by, it's actually a collaboration between people at Google and people at Mozilla to do SSL poorly. To really, you can look at it if you go to badssl.com. There's a whole list of what not to do when you do HTTPS on your website. It's pretty cool. This example here is of a site that is not HTTPS and accept a password field. And lately, I think in the last 6 months, both Chrome and Firefox have added a warning for users that input their passwords in password fields like that are not protected by HTTPS. And when they do so, Firefox would actually say, this connection is not secure, logins entered here could be compromised. It's pretty scary. Like the first time we did it, we had a lot of web developers come to us and say, what is this nonsense? You're scaring my users away. This is terrible. I'm losing market share, et cetera, et cetera. But our mission is to protect the users of Firefox, right? And if web developers are doing things that are potentially dangerous, then it is our job to tell them to stop doing it and to do secure things. We can't keep, sites that send passwords in clear text across 150 routers and 20 ISPs of the internet and not be concerned about that. So in 2017, HTTPS is a prerequisite. If you're building a website, it must have HTTPS. You don't even think of enabling it with HTTP and doing HTTPS later. Do it the simple way. Do HTTPS right now. Make sure all of your resources load across HTTPS connections, and you will have no problem deploying this thing. It will be so much easier than trying to migrate the site over to HTTPS. We've had a few stories, I think if you look in the various Mozilla blogs, of helping news companies. I think I think it was the Washington Post that made the move to HTTPS, and we helped them do that. I'm not entirely sure if it's a Washington Post. And we wrote about it, and it's actually pretty complex when you have a live massive web application to move them over. So you want to do it day one, and you will have a lot less problems. So how do you do it? Let's encrypt the. Pretty straightforward, that one. So I trust everyone here knows. Who doesn't know what Let's Encrypt is? Good. Nobody. So Let's Encrypt really changed it changed the HTTPS world, essentially. We've had like a major increase in HTTPS sites since Let's Encrypt launched, I think 2 years ago. I think it must have been 2 years now. And it really worked. That's what people needed. It's a free certificate authority that's easy to integrate, easy to automate in their websites. Because if you've ever tried to buy a certificate from a certificate authority, it's pretty difficult to do so, right? If you're a big company, you probably have an account that's easier to use and some automation around it, that's fine. But if you're alone and you're trying to click through the website, it's not that easy. HTTPS with Let's Encrypt is so trivial. Today, it's essentially running a tool on your server that goes talk to Let's Encrypt, says, hey, I'd like a certificate for these domains. Let's Encrypt comes back saying, sure, put that random string on your web server just to verify that you own it. You put that random string, the tool does it for you. And then you go back, say, all right, I did it, give me a certificate now. Let's Encrypt says, okay, here's your certificate, and done. Right? That's called ACME. That's the ACME protocol. And that is all transparent to you for the most part. You just need to run the tool on your server, and everything gets configured. And it is so transparent that more and more web servers are actually building it into their core functionalities. So Apache now has a mode, Let's Encrypt, or I forgot what the name of it is, but basically you say, yeah, give me a cert, and Apache will do it for you. And there's a couple of libraries. I know the ones for Go, but there are some for other languages as well, where essentially in your router you'll say, yeah, give me a certificate when you boot up the app, and it will do hold the handshake for you, and there you go, HTTPS. So it's much, much easier to integrate and automate today than it was like 2 or 3 years ago. But that's just the first part of doing HTTPS. The other part of doing HTTPS is actually configuring your Cypher suites. So when Firefox goes to talk to a web server that does HTTPS, there's a whole bunch of handshakes that happens there. And some of that is to negotiate the crypto protocols and decide, okay, I'm going to use this version of the AES algorithm. Some of this is like, oh, I'm going to do some Diffie-Hellman stuff and all of that mumbo-jumbo. And it's pretty complicated. And I think it was 4 years ago, I, myself and a couple of the folks at Mozilla wrote a wiki page to essentially list how you should do HTTPS. And it's just one way to do it. It's called server-side TLS. It's on the Mozilla wiki. And it tells you just to take that snippet of configuration, put it in your server, and you're done. That's the only thing you should be worrying about. And it turns out people really needed that because they were all trying to figure out exactly what Cypher suite they should be using and what configuration. It was really complex, and people would get it wrong, or they would do it once, and 6 months later, the crypto world would say, oh, don't use RC4 anymore, and people would be like, what? So it was complex. So what we did is that we wrote a few tools. This is the TLS Observatory tab of observatory.mozilla.org to help people test their configurations. There are other tools out there, popular one being SSL Labs, also very popular. And you can use them to test your configurations. If you have an HTTPS website, every once in a while, go look at these sites and test your config. If it returns a warning that you're not doing well, you can use a configuration generator. So this is the one we wrote at Mozilla. And you say essentially, I have Apache, I want the intermediate configuration level because I need to support these browsers, for example. And this is my server version, my OpenSSL version, and it will give you a snippet at the bottom. You can just copy and paste in Apache. And that's all we really need to do. Ideally, if you're only interested in making websites, you don't even manage Apache anymore, right? We're going to talk about that a little bit. But if you use a provider like Cloudflare, for example, or Heroku, chances are they will do HTTPS for you, and they will actually configuring for you, and they are responsible for doing it right, and they do. So that's even easier than having to manage your own web server. All right. That's all well and good. And we've probably done all of the right things to secure our website. But websites are complex, right? That React contact form is pretty massive, and there are probably a lot of holes in it that we haven't found. So we need to try to find these holes before someone else does. That's where security testing comes into play. So security testing is complicated. It is something that people specialize in. I actually put like 4 areas here, and each one of them is an entire specialty. So you don't want to spend the next 3 years, or you can if you want to, but that's not the goal here. What you want is just to know enough to test your application every once in a while. So we're going to talk about them. Web application vulnerability scanning is the most common one. Fuzzing is interesting, a little more sophisticated. Static code analysis is something I really recommend developers to look into because it's very close to the source code. And relying on external researchers, this is probably when you start having a little bit of money on the side and you can have other people help you. So web application vulnerability scanning essentially is about taking an external tool, pointing it at your website, your web app, and letting it run. Most of the time, they come with default configuration that are pretty good. This is a screenshot of the OWASP Z attack proxy, ZAP, which I like a lot because the guy who made ZAP actually works in my team. So we use it a lot internally. And I think a lot of people outside of Mozilla also like to use it quite a bit. So it's a good place to start. It's open source, it's free, etc., etc. You can download it, it's a Java application, and run it against your website right now, well, after this talk. And what this does, essentially, is you say, all right, go look at this app and tell me if you find anything wrong. And Zap will go and parse the HTML and spider every resource in there. And every subpage that it finds, it will parse it and find other resources. And it will constrain it to the origin. So it would not go like scan Facebook. It will just look at your site. And for each resource that it finds, it will evaluate the resource against a set of security rules. So if you have, for example, cookies without a secure flag, might be an example, it will tell you, hey, you don't have a secure flag on your cookie, et cetera, et cetera. It's a great way to have an external tool review what you did when you wrote your application and make sure you haven't missed anything. Some of these things are what we call false positives. And it's very hard to reduce them because for some people, a false positive is irrelevant. For some others, because of the way their application works, it's actually a critical issue. So these tools are by definition very verbose, and you have to go through them, through the results manually. But it's also a learning exercise. So I find it very interesting. If you have a modern application, the problem with a lot of these tools, and Zap is one of them, but you have like some you can pay for, like Quadis, for example, or a bunch of other open source ones, Arachne, WAF, et cetera, et cetera. And they all pretty much work the same way, but have, it's best to use more than one if you can. And the problem with all of these tools is that they need to essentially replicate a lot of the functionalities of the browser. They need to go talk to a site and parse the HTML and reconstruct the DOM and everything. And that's difficult to do. So another way to do it, especially like if you're a React developer and you have the whole virtual DOM thing going on, most of these tools don't understand a thing about that. So it's better to use it as a proxy and actually have your browser visit the site through Zap or through whatever vulnerability scanner you use. And that way, Zap doesn't need to understand how to spider the site. It just uses whatever the browser is requesting. Right? So you can do that too. And this is actually pretty easy. In a couple hours, you can get that working on your development machine and just use it every once in a while before you push the product, because, as part of your QA process to make sure everything is configured properly. Fuzzing is kind of a zoom in to vulnerability scanning. And the idea here is that you have, for example, an input parameter on one of your API endpoint, an integer at the end of your round. And you want to make sure that that integer is always treated as an integer and someone cannot just inject HTML in there. And that's fuzzing, essentially. You say, this is my input parameter, and go try to inject as much junk as possible in that input parameter to see if you can blow up your application. And a lot of applications will blow up. They will just, when they receive 20Ks of bytes instead of a small integers, they just stack trace and everything, bye-bye. In the worst cases, you can actually use that to go mess with the memory and trigger a remote code execution. We use fuzzing essentially on desktop applications. So there's a whole team of like 7 people that does fuzzing on Firefox. They find hundreds of bugs every year. And they're very successful because Firefox is a C++ mostly applications, and it's very hard to manage memory the right way. And it's such a complex beast that it's easy for a developer to, I don't know, for example, misuse a variable and end up opening up an attack vector. And the fuzzing team goes in and injects all sorts of junk into all of these interfaces and blows up Firefox. And when they find an issue, they go to the dev and say, all right, we need to put a fix there or a little guard here or something like that. You can do the same in your web application. Most of the time, if you use a stable web framework, you're OK. You don't really need to do fuzzing. But if you're starting to do things on your own, you probably want to poke at that at some point. All right, the one I really like for web devs to invest some time in is static code analysis. And that's essentially using a tool to go look at your source code and find issues in it. So for example, here, Bandit is a static code analyzer for Python applications. And it found an issue here in one of our projects called Kinto. This is actually a false positive, but it illustrates the point quite well. And it found a high-risk, high-severity issue. It's pretty confident it's an actual issue because the input method actually does not sanitize the input. So if someone passes actual Python in there, then it will get executed as Python code, which is pretty bad. So I think use for the username, and someone puts a whole chunk of Python in there, and there you go, you have a remote code execution on your app, right? For various reasons, including the fact that we actually use Python 3 on Kinto and not Python 2, and that issue only exists in Python 2, we're not exposed to this. But a static code analyzer will go look at your source code and say, hey, you probably shot yourself in the foot here. You probably need to add a guard. You have static code analyzers for Python, for JavaScript. ESLint is a very good one. Look for one in your language. It's also very easy to automate this in continuous integration and to run it automatically. The same way you would run like a code linter or some, for example, a formatting tool in your CI, you can run static code analysis. And so that's really how you should approach these things. If your development workflow essentially is put something on GitHub and have a CI tool, run a whole bunch of tests before you merge that pull request, then you should put your tests in there as well. And a bunch of these tests, they can go directly in your CI environment. So what we did at Mozilla is we took Zap, and it's a big Java application, so we put it in a Docker container. And we put that Docker container in a bunch of our CI, and every time a new pull request arrives, then we run Zap against the version of the code that isn't even merged yet. You can do that with static code analysis. You can do that. Well, fuzzing is a bit more difficult, but you can actually, if you can constrain your tools to look at specific things, then it's a good fit to put in CI. And what is interesting here is essentially you're reviewing your code for security issues before it's merged in the production branch, before it goes live, right? So you're actually avoiding the entire someone found a bug and we need to do an emergency release on a Sunday morning, but I'm on my laptop on a shitty connection because I'm, I don't know, kayaking in Florida, something like that, then that's true story. These tools will help you prevent that. So test early in your CI pipeline. So if you use Circle CI, Travis CI, whatever, this is how you would do it, essentially, in your test section. Say you have a Docker container of the CuteFox application, and you run that in your CI. And then you use your scanner to go poke at that application that's running locally. All of that is happening inside the virtual machine of the CI tool, and it's running every time someone submits a patch. The kind of results you want there, you want to avoid false positives. So you want to reduce that to very, very kind of unit tests kind of way. Right? You don't want to have a whole bunch of false positives that you have to sort through every time you submit a patch. So what we did is we picked a few very specific tests. For example, we want to have content security policy on all of our applications. So we put a test for that. And if the test fails, we know that CSP is not enabled, so we don't want to merge that patch. The good thing about this is applications will slowly degrade over time. The perfect CSP you put at some point 2 years ago is probably gone by now. And by having automated testing, you guarantee that these regressions don't get into your app. that you keep it at the same security level. And that's pretty important because you can't keep an eye on everything. So you want to invest time doing security once and then make sure it stays there over time. You don't want to redo that every 3 weeks. All right, and the last thing I'm going to talk about today is relying on external researchers. So I mentioned that we have a web bug bounty program. We actually give people money. If you're not doing anything on the weekend, that's a good way to make a few bucks. If you find, for example, a remote code execution on what we call a critical site, so say Firefox accounts, for example, then we'll give you $5,000. A lot of big companies do that. You can look at Google, Microsoft, Facebook, Twitter, et cetera, they all have the same kind of program. It's a good way to invite people who are going to poke at your websites anyway to report it to you first and not publish it on some random mailing list where you'll have to do essentially emergency response. The rules are pretty simple. It's a confidential report of the vulnerability. You fix it, they get paid, and then you open up, or you don't if you want to stay confidential, but we usually, at Mozilla at least, we make all of that public. So 3 weeks, 4 weeks after it's been reported and we fix it, we open up the bug and everybody can look at it. The benefit of this, and you can use any sort of third-party vendor to run that program for you, is you're putting your company out there as we're serious about security, right? We really want to do business. We really want people to trust us, and we're going to play by the rules. And today's internet rules are people that come, look at your application, poke at it, break it, and let you know about it. And you can either take the knee-jerk reaction approach of like, oh my God, we're going to send the lawyers at you, or you can play it properly and actually work with these people who are really, really smart, and they just want a few $1,000 to fix your app and actually make everything more secure. So I really encourage you to look into that. Probably not something to do if this is your weekend project, because it's a bit expensive, but if you have a successful business, you should do that. And if you really have money, which is always a good thing, you should spend it. And a great way to spend it is to go ask a third party, a security specialist, to destroy your website. And you literally ask them, just blow up the whole thing if you can. Probably not the production environment. Give them the staging environment, it's best. And we do that regularly. We did that with Firefox accounts last year. We did it with addons.mozilla.org this year, Firefox screenshots, new feature as well, where we go ask vendors to take the source code, take the stack, take the infrastructure, and find issues in it. And the real benefit of this is, well, first of all, it's really high-class security data that you get out of this. It also trains your team. And when we do these exercises, the security team drives it, but the dev team and the ops team are both heavily involved with it. And it's a training exercise for everybody. It is traumatizing when you've written 10,000 lines of code to see that there's a major remote code execution in the middle of it. Right? Some people don't take it well. That's why you need to do these exercises regularly so people get used to them and actually get used to the actual process of finding and fixing security issues. If you can, make the reports public. It actually, again, increases the trust in your company. You can't always do it. Sometimes stuff that is in the report isn't really for public consumption. But if you can, make it public. How about securing your servers? I have another 42 slides. No, I'm kidding. The short answer is, do you really need to actually have servers? And it all depends on the size of the organization. But if you're a small shop, and by small I mean probably below 20 people, you really shouldn't be doing a whole lot of ops yourself. Just go get a trusted vendor. Go get Heroku, go get AWS, go get Google Cloud, whatever, DigitalOcean, all of these guys, and have them host the application for you. Benefit of that, they will do all of the server security for you. They will do all of the patching, the update, the whatever, and you just give them a packaged version of your application, and they do all of that work for you. My recommendation, if you're a small shop, don't try to do ops. If you're a big shop, then let's talk, sure. But you probably shouldn't worry about it. And even for us at our scale, sometimes we just tell people, go put your app in Heroku. Because we have something like 2,000 websites, and I don't want to secure every single one of them. All right, so if you want to learn more about these things, we have wikis, I mentioned the book, but go check out the wiki if you want. There's a lot of resources out there. Mozilla Developer Network is a great place to start. Contribute to it, ask questions. We have an RC security channel, good place to ask questions too. So reach out, don't hesitate. And again, stay out of the news. Don't be Equifax. Secure your websites. Thank you.